So this is our app, and that's an app for parking in Seattle. We're trying to predict the occupancy ratio based on parking records, land use, parking rates, and street hierarchy. The motivation for our algorithm was that parking has become a serious problem in the United States. It consumes a lot of land and turns cities even more expensive than they already are, and also causes a huge externality because people keep driving and searching for parking spot that is known as cruise. So it raises a lot of emissions of greenhouse gases. And the use case for our app would be for planners meeting with developers or another agencies, and they would have a quick response for parking demands if they wanted to change something in the urban scene. The way it's done today by the city of Seattle is that they have this control of a sweet spot. They don't want to have like too much vacancy, and they don't want to have that high ratios of use, so they try to control that with changing prices dynamically. So in order to build our model, we gathered lots of data. We used the Seattle streets data, and we aggregated to that the building permits data, which is every building permit issued or in process today. And we used that as a proxy for land use. So here you can see all the segments in the study area for the parking annual study. Some of the areas do not have any stalls, so we actually find it better for our model to remove those from our set. And here you can see the occupancy rate during the day. It's easy to see that during the afternoon it is the busiest period, followed by the evening and then by the morning. You can confirm that seeing here the distribution in this bar plot. Afternoon is way much occupied than other periods of the day. It's noteworthy that this is a downtown area, and it's mainly commerce land use. So we decided to do a parking score, which is we aggregated all the kind of land use per segment, and we weighted them and summed so that each segment has a parking score. And here are the rates that we used. And we use that to build our model. Our model we applied to a train set, and it had a mean absolute errors of 50.51, and the mean absolute percentage error was 4.45%. We also did apply those to a test set. And this is how our model would work. First, you would select the study area. Then our app would return some preliminary info about this area. We would ask the planner to input some parameters to the selected area. And our app would return information regarding parking demand in the area and how many new parking spaces they would need. We aim to improve this model by gathering data about building height. Unfortunately, that was not available. We would also like to integrate some variables about the weather and the different seasons. And we should also try to separate our data between weekdays and weekends. I hope you like this model and this app proposal.